Hello everyone, and welcome back to another professional prep video. In this video, we're going to be defining derivatives, and we're also going to be talking about two types of rates of change actually. Average rate of change, which you're already familiar with most likely from algebra classes, and a new rate of change, instantaneous rate of change, which ties in very well with derivatives. So we'll talk about those two things, but sort of as a warm-up problem, I guess, I want to do a quick average rate of change, just to refresh our mind. Calculus is the study of change, rates of change. So that's what calculus is. So that's why we're going to see a lot of limits. Was a nice way to sort of get us into rates of change. Now we're going to start seeing actual derivatives, which you've probably heard that term. And it's gonna get great, and it's a lot very interesting. So let's get started. So AROC is how I abbreviate average rate of change. You'll see IROC is just how I abbreviate instantaneous rate of change, just so I don't have to write the whole thing out, just so that everyone's aware. But let's do average rate of change of x squared over the interval. Let's go 1 to 4. So I'm going to work this problem in order to solve this. It's pretty simple, just a little bit of substitution mainly. So, sorry, I should probably define, let's call x squared f of x, and let's say we're finding the average rate of change from 1 to 4 of f of x. Sorry, I should probably define the function. So the formula for average rate of change, as you probably know, it's just some direct substitution to get going. So it's just going to be f of 4 minus f of 1. And all of that is going to be over 4 minus 1. We could solve this out. I think it would end up being, let's see, f of 4, 16, f of 1, 1. So that's 16 minus 1 over 4 minus 1, which is going to be 15 over 3, so that's going to be 5. So our average rate of change of x squared over the interval 1 to 4 is going to be 5. And like I said, that's just a bit of a warm-up question to get us going and refresh us on rates of change. But let's head into some derivative stuff now. So I'm just going to reload the page. So for derivatives, let's talk about notation for derivatives first. So d over dx is a very common one you'll see. Derivatives, defining them, they're just the slope of the tangent line at a certain point. So for example, the derivative of 2x is just 2, because the slope of 2x everywhere is 2. Derivatives and slope go hand in hand. And so we'll talk more about how to actually evaluate derivatives in future videos. That's going to take many videos. It's actually not very straightforward for defining derivatives. I shouldn't say it's hard, but there's a lot of rules to know, so we'll certainly get into those later. But for now, let's just take a look at some notations. So d over dx of f of x. This is something that you'll see. D over dx is a very common way if you have an expression for f of x. Say that you have an equation for y equals something. Then you'll see dy dx like this. You don't really say the over. It's not dy over dx. It's just dy dx. But all that this notation means is it's the derivative of y with respect to x. So say that y equals, let's do 3x plus 5. Then we're taking the derivative of y with respect to this variable x. So that's all that this notation means. Say that it were dy dz, it would mean that we have to take it with respect to z. And we'll talk more about that going forward, but just understand that this notation, dy dx, translates to the derivative of y with respect to x. And the last notation that I really want to talk about for finding derivatives, last notation for derivatives is say that we have f of x equals something. let's just pull that same example I just had. Say that f of x equals 2x. Let's just do 2x squared. Obviously, you probably don't know how to find the derivative of 2x squared yet. We'll talk about that very soon. But just to show you guys the notation for the derivative of that is just that apostrophe in between the f and the first parenthesis. And we read this as f prime of x. So that apostrophe basically just means prime. And that would equal 4x. But we'll talk more about why it's 4x going forward. So yeah, those are all of your notations that we're going to be using and the most common notations for derivatives in our videos. Like I said, the definition of a derivative is just the slope of a line at that point. The slope of the tangent line at that point, I should say. So let me go into our last part of this video. I promised everyone a rate of change, so let's talk about the other rate of change we'll be discussing a lot in calculus. That's going to be what I call IROC, but what most people call instantaneous rate of change. That's all. That's just what that stands for. So we mainly talk about instantaneous rate of change at a point. So, for example, in order to evaluate instantaneous rate of change at that point, you would just take the derivative of whatever function we were given, and you'd plug in that point. So, for example, let's say that we wanted to keep this f of x in mind as we do this example. Say that we wanted to find the instantaneous rate of change of f at x equals 3. So the way that we go about that is we would take the derivative of f of x, and like I said, we'll talk more about how to do that later on, but for now, take my word for it that the derivative of 2x squared is 4x. So f prime of x is 4x, and we're looking for at x equals 3, so we just plug in 3 into that equation, and we get 4 times 3, and 12. So that's how we're going to evaluate the instantaneous rate of change at a point. For now, just keep in mind average rate of change is your algebra definition. Instantaneous rate of change is your new calculus concept. And you take the derivative to find it. I'm looking forward to exploring taking different derivatives. And that's probably what I'm going to be doing in one of my very, very soon videos. So please stick with me for that. Looks like I forgot a parenthesis there. But that's all I have for you for this video. Everyone, please make sure to like and subscribe. And please reach out to us if you have any questions. You can email us or you can leave a comment. Thank you, everyone. I will see everyone for our next video. Have a great day.